a second. So right now I'm sitting at our demo bench, and I actually have over here set up the DL950, and I have it set up with a 3-phase motor at the moment. We'll go over a few things about it. So the DL950, like I said, is high-speed data acquisition. One second, I'm getting some comments that the audio might not be right, so let me look at that really quick. Okay, so we're good. Everyone can hear me. All right. If anyone can't hear me, please let me know in the chat. Okay. Sorry about that, everyone. So like I said, it seems like my audio, it seems like my audio might not have been working at the beginning, so I'll just start over just in case. So like I said, this is Yokogawa's Test and Measurement Department, and today in this live stream we're going to be talking about the DL950 ScopeCorder. Now 2 audios. Okay, I'm sorry, we are figuring this out. Okay, it's better. Okay. Okay. Sorry about that, everyone. Might be able to tell it's our first live stream. Okay, we're good to go. Okay. So, Yokogawa Test and Measurement. We make a variety of test and measurement products ranging from power analyzers, high-speed data acquisition, oscilloscopes, handheld test and measurement products as well. So today I'm going to specifically be talking about our DL950 ScopeCorder, and I'm going to be going over power analysis and the recording methods that you can use and some of the software that you can use with it as well. But I just wanted to keep this chat open to where you can ask me any questions you have about the DL950. It doesn't have to be related to what I'm talking about. We're here to answer any questions, but my specific demonstration is going to be going over, like I said, power analysis, software, and the different recording methods. So I am currently sitting at our demo bench that we have set up here, and I have a DL950 with me, and right now it's attached to a motor kit, and it outputs 3 phases of voltage and current. So what is the DL950? For those of you that don't know, it is a high-speed data acquisition product. So what does that mean? It's kind of a mix between an oscilloscope and data acquisition. So it has the long-term memory and recording capabilities of data acquisition, but it still can sample at those fast speeds that you need. That's more like an oscilloscope. It's also triggerable, similar to an oscilloscope as well. And if you can see here, on the side there's 8 slots for input modules, and these input modules range from being able to read voltage and current to torque, temperature, and a variety of other different input types. So it's really versatile in what it can do and what it can measure, and you can see all of those at the same time on the ScopeCorder. So turning it back, I'm actually going to switch to a view where you can see the screen in better detail on the computer using our software, but just go over a few things on the front display. So we have the waveform set up here. You have a set of buttons over here and knobs that you can use, but it's actually fully operational from the touchscreen as well, so you can use it however you like. For those that may be more familiar with the DL850, for example, you can use all the buttons very similar to that. But like I said, it's fully operational from the touchscreen as well. So what do I have set up right now? Like I said, I'm going to a brushless DC motor, and that's where all of these inputs are coming from. So I have 3 phases of voltage and 3 phases of current. So right now I don't have a neutral present, so I have it in what we call a 3V3A wiring. So what that means basically is that the voltages are line to line. So here in this first input, this is just, I have it set up on some of our voltage input modules, and so they're just B and C inputs. And I have my first phase of voltage, and then I have my current, which is hooked up using a current clamp right now. And then I have my second phase and my third phase of voltage and my second and third current as well. So 6 inputs in total, which you can see set up on the screen right here. So I'm going to actually switch it over to our software. So this display that you're seeing right here, this is the exact same display that I'm seeing on the ScopeCorder. Like I said, this is just a remote control view from our IS8000 software. So I'm just going to be operating everything from here instead of the scope, because it gives you a bit better of a visual. So, like I said, I'm going to be going over power analysis. So here are my voltage and current inputs. These first, this yellow and green and purple waveforms are our voltage, and then this blue and light pink and light blue are current waveforms. You can see if I load down our motor, you can see those changing. These currents are increasing right here because we are recording right now. So I'm going to stop the measurement so I can go in and set this up. One of the things that I love about this instrument is we have an application button. So some of your most common applications that this ScopeCorder is used for, we have easy setup features on here. So I'm going to go into power analysis. There are 3 different modes, so either off, 1 wiring system, or 2 wiring systems. And this is, we're selecting 1 wiring system because we have, the 1 3-phase system set up. But if you had 2 systems, or if you were doing efficiency measurements, you could do that as well. So next we'll click on the wiring. So there are many different options for wiring. 1-phase 2-wire, 1-phase 3-wire, 3-phase 3-wire, which actually uses 2 inputs instead of 3. The 3V3A that I was talking about, so this is for line-to-line voltage if you don't have a neutral present. 3-phase 4-wire would be if you do have a neutral wire present. You could select that. And then all of these down here with the arrows, these are conversions. So a lot of people, because you are measuring line-to-line voltage, these voltages are in reference to one another. And that just means that you're not going to get the power that you necessarily expect because they are referenced to each other and not referenced to a neutral. But if you wanted to see those calculations for power, if it were connected to a neutral, the instrument can actually calculate that for you using some of these transformations down here. But we're going to select 3V3A. And then here you just set up where your voltage, your first voltage, current, your second voltage and current, and third voltage and current, which inputs those are related to. So like I was saying earlier, I have my first voltage on channel 1, and there's an _1 here because this is actually a 4-channel module, so it has sub-channels. That's just what that represents. But I already have all of these set up, but you could just go in and select your channels. There's actually a wiring diagram down here at the bottom too, so if I were to change it over, that Can you hear me now? Did we get it fixed? Sorry about the audio again. If someone can comment if you can hear me. Sorry about that. Okay, we're good to go? Okay, thank you. I'm not exactly sure when it cut out, but I'll just go back one step. So essentially I just set up the wiring here for my three-phase system, and then I set up all my input channels. Okay. So the calculation period, like I said, there's 3 to choose from. This is just calculating it based on an edge, and that edge is going to be, that it uses is based on this edge source that you choose. Typically you just want to choose whatever your most stable signal is. I'm just going to choose U1 here. You can set your hysteresis and an edge source filter. We would typically recommend turning an edge source filter on just to filter out any, this helps stabilize the signal. It helps the instrument recognize that timing that it needs. And just make sure you set it high enough to where you're not cutting out any of your actual signal. And then these are just some different options for the analysis. Your RMS type, if you want your phase angle in radian or degrees, your reactive power formula type, different things down here that you can set. The instrument can also do integration, so you can set some things up for that. So efficiency, a lot of people will use this instrument for efficiency calculations. And so you can select either motor efficiency, or if I were to go back here and have 2 wiring systems, so say I had 2 3-phase systems here that I was measuring, we could set this efficiency measurement for power efficiency as well. Turn that off, or sorry. So with motor efficiency, if you had your speed and torque set up, you could calculate the mechanical power. The instrument calculates the mechanical power, and then you can set this efficiency equation up to see what the efficiency of your motor is. And here's where you select the items that you want to see. I'm just going to click on a few here. I have selected the RMS voltage and current, the power, and the power factor as well. There's a whole list of these items that you can select from, and these are items that you would typically see for power measurements. Like I said, we have voltage, current, power, apparent power, reactive power, power factor, your phase angle. You have your peak values as well. So a variety of different things that you might need to see. There are a lot of options here. You also have the mechanical power. If you're doing integration, you have the time, you have your watt hours. So let's see. Like I said, I selected the sigma voltage and current and power. The sigma is what you would want to select for a three-phase system that that does not have a neutral present, because like I said, those voltages are in reference to each other. And your power value, you're going to end up getting what seems like it might not be the correct power, but your sigma power is that one that you want to look out, because it calculates it based off of the line-to-line voltages. Oh, I also have the frequency selected as well. And then we'll just click Finish. And it's going to take me over to the power display. So I have my RMS voltage, my RMS current, my power, power factor, and my frequency as well. So I'm just going to go ahead and hit Start on that. So there we go. Now we can see it running, and I can switch back also to that first display with my waveforms. So these are the raw waveforms, but I can also look at the RMS. So these are kind of trends of the RMS. So again, if I load my motor down, you can see this current even went off the screen because of how high it went, and you can see it coming down here. You can also add these to the same display if you wanted to see the raw waveforms along with those calculated RMS values. But I see we have a question here about can the DL950 measure harmonics? So the answer to that is yes. Let me pull this up. So the same way we have a application for the power, we also have that for harmonics as well. So I can go through that really quickly. So we can turn this on to RMS or power, select our source. So this is my voltage on channel 1. Similar thing here with the calculation period. And then my items. So these are all of my harmonics that you can select from. And then we can actually turn on a list display or a bar graph display. I'll just select bar graph for right now. And this will actually show up at the bottom of the display. You can move this display around as well. But these are the actual values of the harmonics up here. We can adjust the scaling to see it a little better. You can actually hit Start so you can see it. But yes, and then you can see your harmonics display graph at the bottom with your power as well as your waveforms. Okay, so that is just a quick summary of power analysis. So now I'm actually want to go into showing a video of what are the different ways that you can record on the DL950. If anyone has any questions, again, stop me before I play this. Go ahead and throw them in the chat. But so the DL950 has a bunch of different ways you can record this data, which is probably the most important part when you are, if you can just display it, I mean, that's great sometimes, but how do you actually get the data out of here, and how do you know what the best way is to get the data out of here? So I have a video on this that I will play for us. And please let me know, I'll hit play, please let me know if you can hear it.
Hi, my
My name is Courtney Turner, and I'm an applications engineer with Yokogawa Test&Measurement. Today I'll be talking about the different memory types on the DL950 and how to pick the best data recording method for you. The DL950 ScopeCorder is a hybrid instrument that combines an oscilloscope and a portable data acquisition recorder that can be used to capture up to 160 synchronized channels of high-speed transient events and long-run trends. Because of these unique capabilities, this ScopeCorder has an oscilloscope mode and a recorder mode. This video is primarily going to focus on the ways to record in oscilloscope mode, but the easiest way to get started with basic data acquisition is to select Easy Recording from the application menu, which walks you through setup in recorder mode. Select your channels, how long to record, sampling interval, and basic channel settings. Press start and you're done. Before I go into the different ways to record data, it's important to talk about the settings that affect how fast and how long the DL950 will record. There are four main things to consider when trying to determine this: record length, time per division, channel count, and sampling rate. Record length is how many data points the DL950 will acquire. This can be set from 10,000 points up to 4 gigapoints. The time per division determines how long the DL950 records. Multiply the time per division setting by 10, since there are 10 total divisions, to determine the total time. For example, 1 second per division is a 10-second recording. The sampling rate is how many data points the DL950 is taking per second. It's determined by dividing the display record length by 10 times the time per division. The number of channels you need to record affects how fast you can sample for how long, so this is something to take into consideration when planning your setup as well. The DL950 has several places to record to. These are the internal memory, solid-state drive, flash memory, and PC storage through the IS8000 software. The internal memory comes standard with 1 gig of memory, but you can upgrade to 4 or 8 gigs depending on how much data you need to store. A quick basic setup to save the data you want to the internal memory includes setting the record length, time per division, turning on the channels you need, selecting each channel's sampling rate, and setting the trigger conditions. Press Start/Stop to start the recording. Once the recording is finished, go to the Save menu to save the data in the format you want. This option is similar to an oscilloscope in that it streams data to an internal high-speed RAM. The data is cleared once the unit is turned off or another acquisition starts. This is the best option if you need to record at fast sampling rates up to 200 megasamples per second for several seconds or minutes. The 512 gigabyte internal solid-state drive is a great option if you need to record for days or months at lower sampling rates. For example, you could record at 2 megasamples per second for 5 hours or 1 kilosample per second for 50 days using the SSD. To set this up, press the Acquire button. Turn SSD recording on, press the SSD recording setup, and set your time per division and record length. The 160 gigabyte flash acquisition memory could be the perfect option for you if you need sampling rates and recording times in between the internal memory and SSD recording's capabilities. For example, you can record up to 20 megasamples per second for 10 minutes or up to 5 hours at 1 megasample per second. The setup is very similar to SSD recording. Select Flash Acquisition as the real-time record option in the Acquire menu and press the Setup button. Select the time per division and record length. Once the recording is finished, you can transfer the data to a PC, SD card, or USB stick. By connecting the DL950 with our IS8000 software, data can be recorded directly into a PC storage in real time. For even faster speeds, the 10 gigabyte Ethernet option allows up to 20 megasamples per second on 8 channels. This is the best option for the longest recording time, and it's hassle-free since you don't have to transfer the data from the DL950 to the PC. For more information on how to use this feature, please check out the video link in the description. While all of these methods allow you to record a lot of data for an extended period of time, there are also ways to avoid looking through hours of data by just capturing the data you need using our advanced triggers, real-time math, and power math functions. Dual capture is also a great option for capturing fast triggered events during a long recording. For even more information about choosing the best recording method for you, please contact us at tmi.yokogawa.com. Thank you for watching. Okay, so hopefully I got the audio fixed while that video was playing as well. So if anyone wants to let me know, that'd be great. So I did get a few questions while the video is playing. One question, let me see if I can pull it up here. All right, so Yusuf asked, when would you use a ScopeCorder versus a power analyzer or meter? So that's a great question because, obviously power analyzers are specifically designed for measuring power and making these measurements, right? Well, the problem with a power analyzer, depending on your testing, is you can't get these raw waveforms out of it the same way that you can with the DL950. So you might need to see this waveform display that I was showing and record that data. The power analyzers do they do have waveforms views available, but it's not going to be at the sampling speed, and it's not going to be triggerable. On the DL950, you can also trigger off of any of these power values, like the RMS voltage, RMS current, power factor, frequency. So anytime any of those go above or below a certain level, those are triggerable, and you can be alerted about that. You can set up an action so it saves a waveform automatically when things like that happen. So that might be when you would use a ScopeCorder. Now for a power analyzer, that's if you're doing benchmarking and you need that high accuracy that a power analyzer can provide. A ScopeCorder is not going to give you the most accuracy if you're doing some kind of compliance testing or benchmarking, like I said. In that case, the DL950 doesn't quite have that same level of accuracy, whereas you're looking at very, very accurate, like 0.01, 0.02% for a power analyzer. So, great question. I got another question. So, is it possible to control and acquire values live via LabVIEW? Are drivers provided, or is the IS8000 software package the only way to access the DL950? So yeah, that's a great question too. Yes, we do have LabVIEW drivers that you can use. You can use pretty much any programming. We have a communication manual that you can pull data off of. And so yes, you can use it with LabVIEW. We have drivers available for that. And so IS8000 is not necessary for doing that. And those are all provided on LabVIEW's website and our website as well. So if you go to the DL950 webpage, you can go to our documents and downloads, and you can find those LabVIEW drivers. Okay. Any other questions, let me know. But the next thing that I wanted to do is, so the video that I just played showed you the different ways that the DL950 can record data, and so, sorry, I was just checking the chat really quick. Yeah, so that showed the different ways that you can record data. As you can see, there's many different options, many different types. You can just select the channels that you need to see and get just that data out. There's different methods, like using different sampling rates and things like that on the instrument, to where you're not getting at so much data, because this can record a ton of data, but then what do you do with that? So that's just something to keep in mind. It's one of our major questions is, how fast, how long can I record? And it's just good to know your options. We also do have charts and things in our manuals if you really want to get down into it and see, if I have this many channels at this sampling rate, how long can I record for? What's the maximum voltage you can bring into the oscilloscopes? Another question I got. So it depends. For us, it's about 1,000 volts max. It depends on the input that you have, the module that you have. and the probing and things like that, but 1,000 volts is the max for the ScopeCorder. But the next thing I wanted to talk about, and I'm going to actually play another video. So we talked about the difference between the power analyzer and the ScopeCorder. We also talked a little bit about the software and tying things together. So the IS8000 software can actually also get data from a power analyzer as well, so our WT5000 specifically. So, because what happens if, hey, I need to see the waveforms, I need to trigger off these events, but I also need the accuracy, and I need that all time synchronized. We used to have different softwares for each product, and now with the IS8000 software, we're bringing all of that together to where you can see it all at the same time, and get those waveforms time synchronized with the accurate data from the power analyzer. So I actually have a video for that. So let me pull that up. It just goes over gives a good overview of the software and the power analyzer, the ScopeCorder, and how you can pull all that data together and different methods of doing that. I'll be monitoring the chat during this, so please bring any of your questions.
Hi, my name is Courtney Turner.
And I'm Cameron Simpson.
We're going to tell you about some of our top products and how you can tie them all together. We found that different engineering groups have different requirements, which oftentimes means they need different types of instruments. While the design teams generally sacrifice cost for quality and time to market, validation and compliance teams sacrifice time to market and test for quality.
This can cause a lack of efficiency, which can result in increased time to market, decreased quality, and excessive spending.
Yokogawa offers a variety of products for each of these engineering groups and the solution to synchronize, configure, collect, and analyze data from all of them to increase efficiency and decrease cost across teams.
The WT5000 is our highest accuracy precision power analyzer. It has 7 swappable and reconfigurable input elements, plus up to 4 motor channels to measure both electrical and mechanical power under one measurement system.
The DL950 ScopeCorder combines the ability of a mixed signal oscilloscope to capture high-speed transient events with the capacity to record long-run trends. With over 20 types of isolated input modules and 8 modular slots, the DL950 can measure 128 channels of voltage and current, temperature, vibration, acceleration, strain, and other electromechanical and physical phenomena.
The DLM5000 is a compact 8-channel oscilloscope that offers a large touchscreen, extensive triggers, math channels, vehicle serial bus, and other analysis features to provide the flexibility users need to capture every measurement.
While all these instruments are great standalone, some applications require accurate power data, fast sampling rates, long recording, and insights that only waveform data can provide.
Our IS8000 software unifies the WT5000, DL950, and DLM5000 into one display for viewing, measuring, and debugging across multiple waveforms.
With one software to set up and control all the instruments you need, you can start measuring data faster and more efficiently.
IS8000 also allows you to store data in one format and location that can be opened for analysis in the software or exported to a CSV file.
All of these instruments can also be synchronized utilizing IEEE 1588 for measurement data you can trust.
To begin assembling our system of instruments, we'll set up the connections between each device and IS8000. For our setup, we'll be connecting our DL950 and WT5000 to our PC through an Ethernet hub. This will allow an Ethernet connection between our instruments to support IEEE 1588 synchronization. The DLM5000 can also be connected in this manner. To set up synchronization between the instruments, we'll first go to the DL950 and enable IEEE 1588 master control. First, press Utility, then System Config, then Time Sync, and set this Time Sync setting to IEEE 1588. We'll then press IEEE 1588 Setup and set the master mode to Master/Slave. Next, we'll enable the Time Sync on the WT5000 by going to Setup, then Utility, and then to the System Configuration menu, and enable Time Sync in the bottom left. Be sure to choose matching settings with your DL950 for proper connection, including network layer, E2E, domain number, etc. The sync calibration period may take a couple of minutes, so you can monitor the progress by pressing the information button at the bottom of this menu. After our hardware is all connected and synced, we'll launch IS8000 on our PC and press New to open a new DAC connection for each instrument. We can use the automatic device search function to find our instruments, or we can find them manually with the address information. When our instrument is located by IS8000, we'll press Open to start a new DAC connection.
The window will now show the waveform capture view, as well as other menus for adjusting device settings and channel settings on all the connected instruments. We'll combine the windows for our units by pressing the ellipsis next to the WT5000 under Devices and starting coaxial connection. We'll also be sure to make the necessary changes to the device and channel settings so that our measurements will show up as expected. When we're ready to capture measurements, we'll go to the Control tab in the Monitor ribbon at the top of the screen. The ribbon will now show the options for controlling the measurement. We'll press Record to begin recording and verify that all our data is being captured. Please note that when you use the Start button to begin monitoring measurement, data is not being captured unless you also press Record. While this measurement is running, you have the option to perform a manual file division if you selected that option in the DAC setting menu.
Once the test completes, we'll stop the recording, stop the monitoring, and verify that all of our data has been saved to our PC's storage. Now that our data has been saved, a new window for analysis will open with all of our recent data. We can also access this file later from its storage directory using the pathway shown in the DAC list submenu. We have the option of adjusting the layout of our data in IS8000 by clicking the header of each subwindow and dragging it to a new orientation shown by hovering over the tiles that appear. If desired, we can change the layout of the data in the main window by clicking within its area and using the main properties menu that appears on the right. We'll change the split to 3 to get a better view of each trace's level. We can also create a zoom window by pressing one of the zoom buttons under the View ribbon at the top. Once it appears, we'll drag it to a new position and adjust the split property to view a single waveform. Using the Zoom 1 cursors that have appeared on the main window, we can coarsely adjust the horizontal zoom. For finer zoom control, we'll click within the zoom window area and use the horizontal scaling button in the Zoom Properties menu.
Lastly, we can convert the data to CSV format by pressing File, then Export to File, and then selecting the CSV extension from the File Type drop-down menu. When CSV is selected, ASCII file settings like time access information and decimal point type are available. When we've selected the channels that we want saved and the settings for the CSV file, we'll press the Save button at the bottom and specify a file name to complete the conversion.
That's all for our demonstration today. In summary, we introduced our suite of instruments and the software solution that ties them together, demonstrated how to synchronize them with IEEE 1588, and showed how to connect and manage data from them using IS8000.
We hope this video helps you let your instruments work together so your engineering groups can work together. Please check the links to the product pages in the description and visit tmi.yokogawa.com for more information. Thank you for watching. Okay, so that was our video, like I said, about tying together that power data from the WT5000 and the DL950. That's really all I had for today, but I want to leave this open for a little bit longer so I can get any more questions that anyone has. So I can switch over.
Okay, let me know. Is it working now? We're good to go. Okay. Sorry about that again. We're trying to figure this audio situation out. Okay, I'll stay over here. Okay. Alright, well, okay, good. Now you can hear me. Okay, good. So I can switch back over here, pull IS8000 back up. Well, you might not have heard, that's really all I had for today. And so I just want to keep this open for a little bit longer while, you know, maybe a few more questions might roll in. But in the meantime, I can just go over a few of my favorite features about the DL950. But if you don't have any more questions, like I said, you can stay on, see some of my favorite stuff. But so I switched back over here to IS8000, or yeah, to the IS8000. So I talked a little bit about the triggers earlier. If I go into the menu, we have a few different ones. So right now I'm just triggering on a basic simple edge trigger, but we do have a lot of enhanced triggers. So A to B, A to AB, edge on A, an OR trigger, AND trigger, period trigger, pulse width, and wave window. OR is really, really cool. I can go set up a pattern over here, and what it does is you can set up a different type of trigger on each of these channels. You can choose between either, let's say, you know, a rising edge, a falling edge, in or out. So the in or out is you can set a width and a level, and you can say, hey, trigger if it goes outside of this, or trigger if it comes in, if it goes out and then comes back in to this parameter. So you can set this up on all of your available channels, and the cool thing about the OR trigger, and basically what that means, which I got a question about that, is anytime any of these events happen that you have set, the ScopeCorder will trigger. So that can be super useful if there are multiple events that you want to catch on different channels. If you have a certain level that you want to stay below, on hand, set that up here. Like I said, there's the width. It's just a really cool and useful trigger. And then the AND is kind of similar, but instead of it being or, like or meaning if any of these things happen, it would be ANDed. So it's if all of these happen at the same time, then it will trigger, which is really cool. The wave window trigger is also pretty cool. It sets up a border around a sine wave, and if it goes outside of that, it'll trigger. That can be something hard to set up. I'll just talk about, stop it. So the different applications that we have, there's one for rotary angle if you're doing those type of measurements, GPS position. So if you had it in a car, for example, it can track the GPS position. Dual capture is really cool. This is essentially if you want to see a waveform and record it for a long time, but also capture transient events on the same waveform, the same channel, you could do that. It sets up pretty cool. I don't have an example signal for it right now, but so we would have the low speed waveform that's just steady chugging along, and then once a triggered event happens, it catches it at a fast sample rate. So that's a really useful feature a lot of people use. The power fail detect is what I was talking about with the wave window trigger. So like it shows here, it sets this border around a sine wave, and it will trigger anytime it goes outside of it.
I don't have a strain module plugged in, but if I did, I could go set up the strain gauge here. Another one of the things that I love about the DL950 is this easy recording mode. So, like I said at the beginning, the DL950 is a ScopeCorder, so a mix of an oscilloscope and a data acquisition. The view that I've been working in, which is this, is oscilloscope mode. So we have those triggers, we have sampling rate to set up, all of that. In this easy recording mode, it sets it up like a data acquisition. So if you just want to record all of these different channels for long periods of time, that is what, and you're more used to a traditional DAC, that's what this sets up as. So you just, pretty easy, just turn your channels on. You set how long you want to record for. You can set it up for days, hours, minutes, seconds. And then based off of that, it'll tell you, depending on your recording time, what your shortest sample interval is. And then you can set that sample interval, which it relates it to a sample rate if that's more what you're used to seeing. And based on how long you set the recording up for and the sample interval, it'll tell you how much space that you have left on the SSD or the memory card that you're recording to. And then you just set up your inputs, press finish, and then you would just press start and it would start recording. It's pretty great feature, makes it really, really easy to set up. So you can see it just filling up the screen. But, well, it looks like I haven't gotten any more questions, so I'm probably going to end the stream here. If you want to drop a comment, tell me what your favorite part is of what we went over today, that would be awesome. We really appreciate everyone that joined our stream, and if you have any questions, post this in the chat. You can visit us at tmi.yokogawa.com. I'm an application engineer, so I'd love to answer any questions you have about any of our products. And there's a lot of resources available, like the LabVIEW drivers that I was talking about earlier, all the documentation, information on all of our products, and additional videos that we have on our YouTube are there as well. So thank you everyone for joining, and I hope you all have a great day.